on notes page number 2. It says chords property number 2. Now remember, I want you to use common sense. I want you to use your brain, your thinking power. This is not about memorizing word for word. It's more about thinking about what these pictures look like and what do you know about circles. For example, take a look at this figure we have. dB. Look at this line dB. Tell me, what would you characterize dB as? Does it look more like a diameter, a secant, a tangent, or a chord? Hope you said diameter. This line dB looks like it cuts my circle directly in half. It looks like it's the total length of the circle going through the center. It looks like it. You don't see the center label here, but if I'm looking at that with my eyes, that to me looks like it's going to be a diameter. And I say that for a reason. We're going to jump into the terminology of this property, but don't let these big words, so to speak, throw you off. So, follow along with me. It says, property number 2, if one chord is the word is perpendicular bisector. Perpendicular bisector. If one chord is a perpendicular bisector of another chord, then that first chord is a diameter. So, the second line says, well, if line dB, so I want you to write in here, if dB is a perpendicular bisector of EC, then dB is a diameter. dB is a diameter of the circle. So we actually kind of figured that out before we even looked at the property. You just kind of looked at this and you could tell that dB was the diameter of the circle. Now we have a property that we can use to prove it. So I actually want to go back and make sure we understand what a perpendicular bisector is. So follow along. I'm going to go down the page. So point blank, simple, a perpendicular bisector is a line that cuts another line exactly in, what does it sound like? Bisect. It's one of our vocabulary words from last semester. It cuts another line exactly in half. And intersects this line at a blank degree angle. So it's a perpendicular bisector. What type of angle do you think it intersects the line at? A 90-degree angle. So this property goes along with another property. So do me a favor, flip over to the 3rd page of your notes. This is chord property number 3. And what it says, and they go hand in hand, they're kind of a pair. If you look at it, this picture looks very similar to the picture that we just finished looking at for property number 2. So it says, if a diameter of a circle is perpendicular to the chord, then the diameter bisects the chord and its arc. And so what that means is, if you see this diameter here, WY, and you see that it's perpendicular, this 90-degree angle box right here, you see it's perpendicular to another chord, then you know that this diameter bisects this chord. It cuts XV directly in half, and it also bisects this arc, XV. So, I know that looks a little confusing now, a little convoluted. When I show you what it looks like in an example problem, it'll become much more clear. So, come down with me to example number 1. In fact, before we go there, I want to make sure this is clear. XZ, line XZ, this part of the chord, is congruent to line ZV. So this part of the line is congruent to that part of the line because it has been bisected. Remember, when we cut something exactly in half, the two halves have to be equal. My tie, I'm not wearing it right now, but my tie was about 6 feet long. If I cut it in half, one half would be 3 feet, another half would be 3 feet. If I cut my tie and now one part of it is 2 feet, the other part is 4 feet, did I really cut it in half? Well, no, I just cut it into 2 pieces. Bisect means cut exactly in half. That's how I know these two segments are equal to each other. So let's see what that looks like. example number 1, this line QS, what that means is I want you to find me the total length of QS. So let's use our properties that we just learned. I see that this is a diameter, and it cuts this chord at a 90-degree angle. You see this box here? It intersects that chord at a 90-degree angle. So what do I know about this chord? It's been cut in what? It's been cut in half. So if this side is 11, what is this side going to be of my chord? It's going to be 11. So now both halves of my chord are 11. The question asks me to find QS. That means the chord, the length from Q to S. Total, that's going to be what? 22. Alright? Pretty easy, right? So let's go on to a little tougher one. And I know you guys are going to be able to get this too. So example 2. Once again, I have a diameter. I know it's a diameter because you see this line, it cuts through the center. That point T is the center there, so I know this is a diameter. And once again, it intersects a chord at a 90-degree angle. That 90-degree angle box is important there. So we know it does what to that chord? It cuts it where? It cuts it in half. So once again, if this chord has been cut in half, that length of the chord has to be exactly equal or congruent to the other half. So this time they gave us algebraic expressions. They didn't give us a number. They didn't tell us the length of the chord is 11. They didn't tell us it was 15. This time they told us that this side is 9x plus 3. 9x minus 3, excuse me. And the other side of the chord is 7x plus 5. So we know it has been bisected, so both halves have to be what? Equal to each other. So I'm going to set them equal to each other. And now from there, all I want you to do is solve for x. We're going to start by doing what? What we always do when we have an algebraic equation. We're going to combine like terms. So I see my 7x, I see my 9x. What do you want me to subtract first? Either way, we're going to get to the correct answer. Hopefully that you said this 7x. We'll take away 7x from both sides. Because if I do that, I'm going to keep a positive variable term. I don't really want to deal with a negative variable. Either way, we're going to come to the right answer. But I'm going to subtract 7x from both sides. 7x minus 7x is going to cancel out. And now I have 9x minus 7x is 2x. I'm just going to bring down this negative 3. So I have 2x minus 3 equals, I'm just going to bring down this 5. So I have 2x minus 3 equals 5. Last two steps, I'm going to add 3 to both sides. These will cancel, and I have 2x equals 8. My last step, you guys know this, I'm going to divide by 2 on both sides. This is going to cancel. And so lastly, x equals 4. Not too bad, right? I know you guys have this. I want you to think about it as common sense. Before you start trying to memorize a bunch of properties, before you start, getting stressed out about the vocabulary words, I want you to look at this diagram. If you didn't know any better, and they just gave you this on a test, let's say you never learned it before, to me, to my eye, it looks like these two sides are exactly the same size. It looks like this line cut the other one in half. That's what it looks like to me. And so before I get stressed out about memorizing a property, I want you to think about it in a common sense way. They are congruent. It's a property. And so we set them equal to each other. We solve for x. All right, one more video left. See you in a bit.